Hey guys, I'm starting with the LeetCode PCD Weekly Contest 489. So, hmm, fourth problem was of try. So, um, even I have not solved the fourth problem. You don't need to worry. We will discuss the first three problems today. So, yeah, first one is toggle light bulbs. You are given an array bulbs of integers between 1 and 100. There are 100 light bulbs numbered from 1 to 100. All of them are switched off initially. For each element, bulbs of I in the array bulbs, if the bulbs of ith light bulb is currently off, you have to switch it on. Otherwise, you can switch it off. Now you have to return the list of integers denoting the light bulbs that are on in the end, sorted in ascending order. If no bulb is on, then you have to return an empty list. So, like in this question, what happens? We have bulbs numbered from 1 to 100, and then if you look at it carefully, first of all, you switched on bulb 10, then you switched on 30, then you switched on 20, then uh, again 10 comes. So since the bulb was on, you will have to switch it off. So the bulbs that will remain on after the operations will be 20 and 30 only, right? So this is the explanation that 10th light bulb is currently off, we switch it on. 30th light bulb is currently off, we switch it on. 20th light bulb is currently off, we switch it on. 10th light bulb is currently on because of the first operation, so we will have to switch it off. So in the end, only 20th and 30th light bulbs are on. Initially, because you are given that each light bulb is switched off, okay? So like here, what will happen? First of all, you turn on 100 and then you turn off 100. So the output will be an empty list because no bulb will be on. So how are we supposed to do the question? It is completely brute force. Um, Obviously, most of the lead code A questions are just simple brute force only. Let me open the whiteboard. Okay, so you have bulbs like this one, two, three, so on up to 100 bulbs, right? Currently, they are off. Let us denote off by 0. 0 equals to off and 1 equals to on. So let us say I give you the bulbs array. Bulbs array as 10, 20, 30, and 10. Now what will happen? First of all, you see that the light bulb 10 is initially off. 10 will be somewhere here. It was 0. Now it will become 1, right? Then you go to 20. 20 will be somewhere here. 20 initially 0. Now it will become 1, right? Then you will encounter 30. 30 will be initially 0. After the operations, it will become 1 again, right? So, and then again you call 10. So now 10 was on, it becomes off. So the light bulbs that are switched on will be only 20 and 30. And that will be the answer that you have to return in your question. Right. So how are we supposed to do it? So you are simply given a bulb's vector of integer. So what will happen? So you are just given this array, right? Now, just as I have this on off state, so let us say that I make a vector of Boolean which is named as on, and its size is 101, and all are initially off, so false, right? Vector of Boolean on, and why is the size 101? Because I need to have indexes from 1 to 100. 1 to 100. So if I want indexes from 1 to 100, the array size should be 101, because the indexing will start from 0, right? 0, 1, 2, 3, so on up to 100. And we are considering up to these bulbs only. But the size of the array is what? Since due to a 0 index in the beginning, the size of the array has to be 101. So I make this array, this vector of Boolean. Now what will I do? I will traverse over the bulbs array. I will traverse over the bulbs array. What will I do? Whatever is said in the question. If on of bulb, if the bulb is on, then you turn it off. Then you turn it off. Else, else means what? The bulb is off. The bulb is off. Then you turn it on. And that's it. Now what will you do? Now you will check whichever bulb is on or off. So you go from bulb number 1 all the way up to bulb number 100. And if this bulb is on, you will say answer dot push back this bulb, right? Not this bulb, but what? This I, right? So this I will push back. Now what is answer? Answer is the final resultant array. We will declare it. And finally, we will return this answer array. So first question was as simple as that. This is the implementation that I have written. Same implementation I wrote in front of you just now. If you have any doubt in this question, which I don't think anyone would be having, you can write it in the comment box. Huh. Okay. Woke up late, don't need to. Okay, so no problem. The third question is a bit tricky as well. The fourth one is of try, so I will not be covering that question today. Okay, so yeah, this is the first question. I don't think you have any doubt in this. No one has written till now. I will I will move on to the next question right now. Yeah, so the next question is this: first element with unique frequency. First element with unique frequency. So basically you are given an integer array nums, and you have to return an integer which denotes the first element, scanning from left to right. So you have to return an integer which denotes the first element, scanning from left to right in the nums array whose frequency is unique. That is, no other integer appears the same number of times in nums. If there is no such element, you have to return -1. So if you are not clear with what is written, let me explain. So like you have this nums array how is the frequency of every element? So like for 20, it is occurring only once. For 10, it is occurring only once. 30 is occurring twice. So 20 has a frequency of 1 and 10 has a frequency of 0, sorry, 1. So obviously the frequency of 1 is not unique because it is taken by two elements. But 30 has a frequency of 2, which is unique. No other element other than 30 has a frequency of 2 in the nums array. So the answer will be what? 30, obviously. Now let us try for this. So 20 has a frequency of 2, 10 has a frequency of 1, 30 has a frequency of 3. Now what you will encounter is that 20 also has a unique frequency, 10 also has a unique frequency, 30 also has a unique frequency. But then it is said that it is said that no other integer appears the same number of times in nums. So yeah, scanning from left to right is written. So first of all, you will start scanning from here. You started with 20 and it has a unique frequency, so the answer has to be 20. In this case, 10 has a frequency of 2, 20 also has a frequency of 2. So there is no element that has got a unique frequency, right? So you will return -1. So these are the three cases that had to be covered. So again, this is a simple brute force question. You just need to know the concept of maps and how to count a frequency of an element in an array or a vector. So you are given an integer array nums. You have to return an integer denoting the first element. Okay, so the question is already clear to all of you. Now we will start with the solution. So like this was the array 20, 10, 20, 10, 30, 30. So 20 has a frequency 1, 10 has a frequency 1, 30 has a frequency 2. So which element has a unique frequency? This one. Now what will we do? We just need to store these frequency first of all. So how will we store? We will make a hash map. We can use a map or unordered map. But what will we use? So map will take O of log n, whereas unordered map will take O of 1. So so what should we prefer? We should obviously prefer O of 1. So I use unordered map, unordered map of integer comma integer named as frequency. Right? Initially it will be empty. Now I will traverse over the nums array. Only nums array is given to us in the question, right? So I will I will traverse over the nums array for int num in nums. What will I do? I will update the frequency of num. So frequency of num will be incremented by 1. Right? This is the way to count the frequency. If you do not know about map, map is just what? Map map is a data structure that stores key value pairs. Key value pairs. So in this num is a key, its frequency is the value, right? So this is how you will construct the map. You will construct the frequency hash map, right? So once you have the frequency hash map, now what you will do? Now you simply have to scan from left to right and check if the frequency is unique. But how will you check that if the frequency is unique? You need to again know, you need to know again that whichever element has got a unique frequency, right? So for that, we will have another unordered map of integer to integer count of frequency, count of frequency, or we will name it as just count. We will name it as just count. Now I will tell you what will count store. What will count store? Count basically tells you how many times a given frequency occurred. Now, what am I saying by this? So, like in this example, one frequency has occurred two times and two frequency has occurred one time. Is that correct? One frequency has occurred two times and two frequency has occurred one time. So that is correct, right? And this is what we will be storing in the count hash map. Okay. Now, how will we know that? How will we know that? We will have to traverse over the nums map, obviously, because how will the nums map look like? The nums map will look like 10, 20, 21, 32, right? So whenever I traverse over this hash map, what will I see? I will see that I encountered a frequency of 1. So count of 1 plus plus. Then I will go to this element. I again encounter frequency of 1. Then count 1 plus plus again. Then I will encounter frequency 2. Then count 2 plus plus this time. And finally, my count map will look like this. Will look like this. Right. That's it. So yeah, an ordered map of int comma int count. So this tells how many times a given frequency occurred. Right. So how will we know that? We will traverse over the hash frequency hash map, right? So we will traverse over the frequency hash map auto and pair in frequency, because maps are what? Maps are a data structure storing key value pairs, right? So you will have to go over each pair and then do what? Count of pr dot second. Pr dot second is what? The frequency will be incremented. So now we will know which frequency has how much count. And now simply we will traverse the array from left to right. Traverse the array from left to right. Again, I will go on each number in nums, each num in nums. If count of frequency of num should be what? Should be what? 1. Then this is the number that I want. This is the number that I want. So I will simply return. If I did not find such a number, I will return -1 in the end. Is that clear? Now, why did I write this statement? So first of all, if I am going on a num, what do I mean by this? If I am going on a num, like I am going on 20, I should know its frequency, right? Its frequency is 2. And then I should know how many times a frequency of 2 has been encountered in the array, right? So a frequency of num, so num will be 20, its frequency will be 2. I'm talking about this array, its frequency, or let us talk about the array we have written above only, so that it is a bit more clear to you. So like, okay, so I go to 20, I go to 20, I go to 20, I see that frequency of 20 is 1, and one frequency has occurred how many times? Has occurred two times. So this is not a unique frequency. This is not a unique frequency. So you do not need to return 20 as your answer, obviously. Then you go to 10, then you go to 10, you see that its frequency is also 1, and then you again see that one frequency has occurred twice. So again, it is not a unique frequency, right? So you will again not have 10 as an answer. Then you go to 30, you see that 30 has a frequency of 2, and you see that two frequencies occurred only once. So it is a unique frequency, and you see that count of 2 is 1. So obviously you will return 30 as your answer. This is how the solution will work. It is also again a brute force solution. You just need to be clear about the working of hash maps, and how do you store frequencies of elements in an array. And the second concept here was that you need to store the count of frequencies as well. You need to store the count of frequencies as well. and whichever frequency has a count of 1, you will return that number, right? So this is more or less the second question. Whatever I wrote in front of you just now is also written in the code right here. So you make a frequency map, you store the frequencies, then you make a count map, you store the count of frequencies, and then you traverse over the nums array because you have been asked from left to right, right? And if the frequency is unique, you will return the number. Otherwise, if you find no such number, then you will return -1 in the end, right? Is that question clear? Is is there any problem that you have right here? So someone is saying jump to C. Yes, I can jump to C, but sometimes some person might be having a problem in B question as well. Okay, so I don't think anyone of you has a problem in second question. So let us move on to the third question now. Hmm. Okay, so this question says longest almost palindromic subsequence, sorry, substring. And this is again not a really easy question if I actually tell you, right? So it is not a easy question if I tell you. Okay, but we will cover this. Uh-huh. So you are basically given a string S of lowercase English letters. Now the string is almost palindromic if it becomes a palindrome after removing exactly one character from it. If it becomes a palindrome after removing exactly one character from it. Now you will return an integer denoting the length of the longest almost palindromic substring in S. Longest almost palindromic substring in S. Now what is the meaning of almost palindromic? A substring is a contiguous non-empty sequence of the characters in a string. Obviously you know that. What is a substring? For example, ABC is a substring of the string, BC is a substring, CA is a substring. So basically a contiguous non-empty sequence of the characters which are within a string. A contiguous word is important here because uh, like A and then you skip again to A, that is not a substring of the given string. Now what is a palindrome? A palindrome is a string that reads same frontwards and backwards. Now what do I mean? So like ABA is a palindrome. ABA is a palindrome. Okay, because it reads the same backwards. It reads the same backwards, right? Now, what is an almost palindromic substring? Almost palindromic means it becomes a palindrome after removing exactly one character from it. It becomes a palindrome after removing exactly one character from it. So, like ABCA, like the string ABCA, is an almost palindrome string because if you remove the character C, then this will become a palindrome. If you remove a character C, then this will become a palindrome. That that is something that we need to know about this question, right? Now, first of all, we just need to return what? We just need to return length of the longest palindromic sequence in S. Okay, substring in S. So how will we do this? First of all, you need to know there are two types of palindromes. Two types of palindromes. Now you might be wondering what are those two types. Okay, so one are the types ABA and other are the types ABBA. So odd length and even length. Odd length and even length. Because in odd length, what do you see? That the middle element has to occur only once, right? So it is obviously the same as the middle element, right? And in the even length, what will happen? There is no such thing because in odd length you have a free character in between, right? If you have a free character in between odd length, that is obviously same as what you read backwards. So I will explain what I'm saying, because when you write this string backwards, it will become again ABBA, and when you write this string backwards, it will become ABA, right? ABA. Now the thing is that this B character occurs only once, but still it is a palindrome because it lies in the middle. So it is not restricted, right? Like what happens, ABCA. Now ABCA is an even length string, but and then the thing is that this C also had to be equals to this B to be a palindrome, right? So middle elements are also restricted in the even length string. So basically I just mean the middle elements are restricted in even length strings, but not odd length, right? So this is what I'm saying. Now if I ask you a thing, how do I actually construct a palindrome? Should I start from these sides or should I start from the center? Should I start from these sides or should I start from the center? So one idea might be to start from outside, another idea will be to start from center. Let us try starting from center. Let us try starting from center, because center, there is only one center, right? There is only one center, or there are two centers, but the position of those will be fixed, right? The position of those will be fixed so that we can simply. So what do I mean by this? So if you want to start from the sides, you need to know both the sides, right? You need to know both the sides. So you need to know L and R both. L and R both. But if you start from the center, you need to know just the center. Let us say I. So preferably we will be starting from the center, because so that we can loop over the center and then start making palindromes, right? So let us try what I'm saying. Let us try what I'm saying. So like you have a string ZZABBA. You could you could start in what way? You could start from the center, right? So you could start from I comma I as the middle element, or you could start from I comma I plus 1 as mid element. Now, what do I mean by that? What do I mean by that? I comma I as the middle element means an odd length string centered at I. And this is an even length string centered at I comma I plus 1. So like here I could have BB as my center for even length, and let us say here ABCA, ABA, sorry, ABA, ABA, I could have only B as my center, right? So these are the two types of cases that we will be covering. Now, what will we have to do? Because we are starting from the center and we can loop over the center in O of n time, and the given time complexity that we can use is obviously n O of n square, since n is 2500. Since n is 2500, n square is what? 625. So like this is 6.25 into 10 to the power 4, right? Just wait a second. बाद में आए ना. So this is what? 6.25 into 10 to the power 6. 10 to the power 6. Now this is less than 10 to the power 8. So it will work. So O of n square is allowed. O of n square is allowed in this question, right? And I am starting from the center. The center are limited only. So you will have possibly n centers for odd lengths, and n centers for even lengths. Right? What I'm saying. So this is what I am doing. So I go to all the i's. I say that I is the center of the odd length, and then I say that I is the center of the even length. I comma I plus 1 is the center of the even length. And let us find the maximum palindrome, almost palindrome that I can get from here. Right? Let us find the maximum almost palindrome that I can get from this I or I comma I plus 1 as the center. Are you understanding this till now? Are you with me? Hmm. Okay. So now what? Now what? Okay, so since I told you about this, now we will see that, let us say I have an expand function which takes L comma R as the input. Expand L comma R means that currently my palindrome is from L to R. We have to expand it sidewards now because we are going outwards, right? We are going outwards, and we are obviously starting at either the center I or the center I comma I plus 1. This is clear, right? So we have made an expand function so that we can expand outwards. Now what? How can we expand outwards? So if S of L is equals to S of R, if S of L is equals to S of R, then we could use this, right? We could obviously use this. Why? Why can we use this? Because we know that the between thing is something a palindrome, and currently we are on L and R. Now, if L and R, this L and this R are also equal, then you can expand it further. Expand it further. You can plan to expand it further. So if S of L and S of R are equal, then you can expand it further. So what will you call? Expand L minus 1 comma R plus 1. Expand L minus 1 comma R plus 1. Right? Expand L minus 1 comma R plus 1. Hmm. And now what? Now what? Now let us say what happens is that you had A, B, C, A, and you start expanding from here. You start expanding from here, right? You start expanding from here. So you see that S of so basically let us say I equals to 1, I equals to 1. So S of 1 is equals to S of 1. So you can expand. So now you will call expand of 0 comma 2. Now this is 0 and this is 2. Now we can see that these two are not equals. These two are not equal right now. A and C are not equals right now. But we are given an option. What option are we given? Option to delete one character from string. One character from string. So we can try both. We can try both. Right? We can try both. So I can try to remove C. I can try to remove C. So if I remove C, then what will happen? Then it will be expand 0 comma 3, 0 comma 3. And if I try to remove A, then it will be nothing because because uh because L will go because obviously A is at the first element, so there is nothing beyond it. So you can only call expand of 0 comma 3 right now. You can only call expand of 0 comma 3 right now. So you might be understanding what I'm saying. Now what? Um, so one thing is clear that expand of L minus 1 comma R plus 1 can also be called, or you can have simply a while loop and you could say L minus minus R plus plus, L minus minus R plus plus till we can expand these outwards, right? And whenever S of L is not equals to S of R, S of L is not equals to S of R, like in this case, A comma C, you can choose to delete an element. You can choose to delete an element, right? You can choose to delete an element. Now, imagine the string was C A B C A, C A B C A. Then what will happen? Then after B, when you expanded to A and C, you could you could delete C and have A B A as your answer, and obviously this length of this almost palindrome will be 4. Or you could choose to have C as your almost palindrome, removing A, right? So you could expand either ways, right? So in this string, like what will we do? We first call expand 1 comma 1. You see that S1 and S1 are equal, so we will go to expand what, 0 comma 2. Now we will see 0 and 2 are not equal, so you could call either expand 0 comma 3. Right. Okay. So this time we called expand 2 comma 2. I'm sorry. I'm really sorry about that. Expand 2 comma 2. So we called 1 comma 3 after L minus 1 comma R plus 1. And then expand 1 comma 3 will call either expand 0 comma 3 or expand 1 comma 4. 1 comma 4. Now both are valid. Both are actually valid. 0, 1, 2, 3, 4. Both are actually valid because here also at A of 1, S of 1 equals to S of 4 equals to A, and S of 0 equals to S of 3 equals to B, equals to C, sorry, right? So, so yeah, this will, this can be done, right? This can be done. Now, what will you take in this case? In this case, you can choose only one element to skip, so you will take the max of these two. Now, you might also be thinking that in this way, though, I can skip all the elements. In this way, though, I can skip as many elements as I want. But the question asks me, the question says, the question says skip at most one character. One character. So you will have to ensure that you cannot skip more than once. You cannot skip more than once. So you will have to add one more state in this, expand L comma R comma used. Used. Used means what? Use can either be zero, use can either be one. If used is false, this means you can still delete a character. And if used is true, this means you can't delete a character now because earlier a character has been deleted. Simply that. So earlier a character has been deleted. So this is the use of this used state, because you need to ensure that at most one character is only deleted. And finally, what will you return? Finally, what will you return? Then you see that there is no further way to expand. You see that L and R, L and R are basically what? L and R are basically what? These are the left and right limits, but these are not inclusive. These are actually exclusive if you carefully think about it. Because why are they exclusive? Because I am checking SL. I'm comparing SL with S of R. So they have not been checked. They have not been checked yet. Not been checked yet. Right. So obviously they are what? They are not inclusive the range, they are exclusive the range. What do I mean by this? That, okay, let me tell you what I'm saying. Let me tell you what I'm saying. Like, like I have A, B, B, A, and then D, and then C. Okay. So what happens is that I start expanding from here. I go till there. I go till there. I I am at this position, but when I am at this position, since L and R are still moving further, L and R still move further. So L will be here and R will be here, but the substring that I will be having is only this, because L and R have not been compared yet. And when you compare, D and C, you recognize that there is there is no use of expanding further. There is no use of expanding further. So what would be the answer? 0, 1, 2, 3, 4, 5. So you will say R minus L minus 1. So 5 minus 0 minus 1 is a length of 4. So R minus L minus 1 will be the answer, will be your answer. So you will be having the answer as R minus L minus 1. But now one more thing for you. What will happen if the used is still false? If the used is still false, what does this mean? Like in this case, in DABBAC, the used will be still false because you have not deleted a character, right? You have not deleted a character, so you can also include this D into your almost palindrome, this D into your almost palindrome, right? So if not used, you can say answer plus plus, because you can choose to have another element that is not in the current string, right? So you can choose to have another element. That is why I said answer plus plus. If you did not understand what I am saying, carefully look at this test case. This test case is exactly what I am talking about. You expand till ABBA, and then you recognize that you have not at all deleted a character from ABBA. So why not take an extra character from the side? So ZABBA could be an almost palindrome. After removing Z, you will get a palindrome. That is correct, right? Now the thing is, what happens if I have something like ABBA CC? Now what will happen after expanding from this B? You will see that L is at 0, 1, 2, 3, 4, 5, and R is at 6. L is at minus 1 and R is at 6, because till here you will have it. Till here you will have it. Now R minus L minus 1 is equals to 6 right now. No, not 6, or actually 6, right? Because 6 minus 1 is equals to 6. Right? 6 minus 1 is equals to 6, right? So R minus L minus 1 is the whole length, is equals to n, so you do not even have an extra character. So you don't have an extra character to delete. Am I clear with this? Because if the whole string is a palindrome, where the hell are you bringing the extra character from? Like in this case, I had the extra character as D. That is why I said answer plus plus. But in this case, I do not have such an extra character, so I cannot say answer plus plus. I cannot say answer plus plus, right? So what will you say if the used variable is false currently, and R minus L minus 1 is not equals to the n, is not equals to the whole string? Then only you will say answer plus plus. Then only you will say answer plus plus. And finally you will return answer. Finally you will return answer. That is what you are supposed to do in this question. You are what you are supposed to do in this question. So if you have any doubt with this, please tell me. Otherwise, I will be explaining the code line by line, whatever I have written. So Pulkit says yes, all clear. So great. So simply look at, first of all, I defined n as s dot size, and I have answer as 0, because obviously I have to take maximas. So answer will be initialized with a small enough value so that I can again take max and max and max to get the right answer. So initially answer is 0. You you say answer equals to max of answer comma expand SII false. What does this mean? I comma I as the center, and currently the used variable is false because you have not deleted any character, right? Or you can expand from I comma I plus 1, and again say used is false because you have not deleted a character still, right? Now, while L is greater than equals to 0 and R is less than N, you will be incrementing and decrementing L comma R, right? So what will happen? If S of L and S of R are same, you can expand further. Otherwise, if used means now you have already deleted a character, so you cannot delete further. So you will obviously have to break out from here. You will obviously have to break out from here. And again, uh, if you have actually used, if you have not used, basically, uh, character character already deleted, character not deleted yet. So if the character is not deleted yet, then that means you can take max, you can put it into else so that it is a bit more clear what I have written, right? So yeah, so you will return. So you can either delete the LH character or you can delete the RH character and expand further. But now, since you have deleted a character, the used will be true so that you cannot delete any more characters. So after all this loop, whenever you come back to R minus L minus 1, that is the length. And if you have not deleted a character and the answer is not equals to the whole length, you can use another character from the sides. You can use another character from the sides. So answer plus plus. And finally, you will have to return the answer. You will have to return the answer. If you have confusion in any part of this question, please tell me, because D question has not been solved. It is the question based on try. So this is the last question for the day. If you have any problem, you can tell me quickly. Amit Kumar is writing, don't start forts, please. Actually, forts, I'm not covering forts today because it is based on tried structure. So even I have not done that question. So I hope that there is no doubt. Okay, Amit Kumar, I have not done the fourth question. So if you have any doubt in the third question, you can still write in the chat box. It was question based on recursion or two pointers, maybe not two pointers, sorry. So Amit Kumar is saying, can you please show the fourth question once? So um, I will explain. Actually, I submitted an O of n squared solutions, so three or four test cases are not passing in that approach, right? Only question you have to see. Okay, so Amit Kumar, you can see this. S- So you're given an array nums and integer k. You have to select a subarray of nums such that the difference between max and min is at most k, and the value of this subarray is the bitwise XOR of all the elements. And finally, you have to return an integer which has the maximal possible value of the selected subarray. So, like 5456, you can select 456. Okay, so currently I will talk about the brute force solution of n square, for which we do not need to use the trie data structure, right? So like 5 4 5 6. Actually, I submitted this brute force solution. Let me submit in front of you as well. Yeah, this only four test cases will be left. Mm. So yeah, obviously I will discuss the solution. So like first of all, let me explain the test case. Like 4, 5, and 6. So the XOR of 4, 5, and 6 is 7, and you can select this subarray because the max of this subarray is 6 and min of this subarray is 4, and 6 minus 4 is less than or equals to 2. So the difference between the maximum and minimum is at most k, that is the condition, right? So we will try to upload the try-based solution in the evening for this question. For now, you can have the O of n square solution from my side. Um, yeah. So let me open the whiteboard now. Basically, what could be the O of n square solution? It is simply going on every subarray. Simply going on every subarray, right? So like I have 5, 4, 5, 6. So I can run a loop. So L 0 to n, and then R 0 L plus 1 to n minus 1 for the of n square solution, right? Now what will happen? You just need to store the max and min over all the range. Okay, so like I start from 5. I can take 5. Currently, max minus min is equals to 0, less than equals to 2, because k equals to 2 for the case. Then I can expand this from here to here. So max minus min is equals to 1, less than equals to 2. I can expand till here. Still max minus min is equals to 1. Expand till here. Max minus min is equals to 1. Is equals to 1, right? So, so sorry, not max minus min 1, actually 2, because 6 is max and 4 is min right now. So yeah, obviously all the subarrays are possible. And now what are the values? So for this subarray I have 5. For this subarray I have 5s or 4. For this subarray I have 5s or 4s or 5. And for this subarray I have 5s or 4s or 5s or 6. Right? So these are the values I can obtain. The most optimal subarray for this question is 4, 5, 6, and the value of that will be 4s or 5s or 6. So for O of n square solution, you can simply go from L 0 to n minus 1, and then you can go from R L plus 1 to n. Right. Now what will you see? Or actually n minus 2 and n minus 1 if you want to be inclusive, right? So what will happen? So basically max equals to nums of L, and min is also equals to nums of R, and initialize your answer with max element of nums, so that all the array, all the I can always take the max element of nums, right? I can always take the max element of nums because 5, because it will be, the range will be, the minimum difference between maximum and minimum will be then 0, which is obviously less than equals to k, है ना? Which is obviously less than equals to k, whatever the k might be, right? So obviously you can take single element every time. So you can initialize the answer with max element of nums. Now max equals to this nums of I, and min is also equals to nums of I, or sorry, L. Now you will uh, keep on doing this. Max is equals to max of max comma nums of L, nums of R, sorry, right? And min equals to min of min comma nums of R. Now if max minus min is greater than k at some point of time, then this R cannot be taken. This R cannot be taken, right? This R cannot be taken. So basically, this R cannot be taken. This R cannot be taken, so you can break. So you can break the loop. Now, if the loop is not broken, then that means answer equals to max of answer comma what? Max minus min. Max minus min. Not max minus min. I'm sorry. Not max minus min. Answer comma XOR. We will maintain a XOR. We will maintain a XOR. XOR equals to currently nums of L, right? And XOR equals to XOR with nums of R, right? So we will have the XOR of all elements in the range from L to R, and we will keep on taking the max. We will keep on taking the max. So this is basically an O of n square solution, O of n square solution, which you can submit. Most of the test cases will pass with this as well. Hmm. Now, the try-based approach will be taken in the evening, right? So, yeah, if I know today try-based approach of n login is not covered, it will be taken by me itself in the evening, right? So, yeah, thank you everyone for listening. I will be sure to share the solution of the fourth problem in O of n log n time as well. Thank you for listening to me.